All right, let's pull back the curtain on how stuff gets made. Today, we're jumping into the world of manufacturing to figure out the different strategies that bring everything from the coffee cup in your hand to a custom-built car into existence.
So, let's start with the big question, right? Why the huge gap in wait times? You can grab one thing instantly, but another takes ages. The answer, it turns out, comes down to a fundamental choice that every single company has to make.
And that choice is all about this constant tug of war between customization and speed. You can have something made just for you, or you can have it right now. Getting both? Well, that's kind of the holy grail of modern manufacturing.
Think of it like this spectrum. Over on one side, you've got high customization but long wait times. That's your custom car. Then, as you move to the other side, customization drops, but delivery is practically instant, like grabbing that coffee cup off a shelf. Literally everything you own lands somewhere on this line.
So what really matters is when in the process you, the customer, get to make your choices. If you get to customize things way up front, early in the supply chain, you get tons of flexibility. But it's going to take longer, and yeah, it's going to cost more. On the flip side, if customization happens late in the game, or not at all, the whole process is way faster and cheaper, but your options are pretty limited. To handle this whole trade-off, companies basically use one of four main strategies. And once you understand these four methods, you've pretty much got the key to how almost everything in our world is produced. So let's break them down.
First up is the one we bump into all the time, make to stock, or MTS. The name really says it all. Companies basically guess what we're going to want, make a whole bunch of it, and then stock it on shelves, just waiting for us to buy it.
Yeah, this is the world of everyday stuff. That can of soup you grab at the store, a basic t-shirt, even the coffee cup from our big question, all MTS. The company is making a bet that you'll want it, so they have it ready to go. It's all about pure speed and efficiency.
Okay, next up is assemble to order, and this one is a really clever middle ground. With this strategy, companies pre-build all the main parts, the modules and components, but they don't actually put the final product together until you place your order.
The perfect example is customizing a computer online. The manufacturer has bins full of different hard drives, memory chips, and processors just sitting there. You go online, pick the exact combination you want, and then they snap it all together and ship it out. It's a fantastic way to get a personalized product without having to wait for months.
Now things start getting a lot more personal with make to order. With MTO, pretty much nothing happens until you give the green light. A company might have the raw materials ready, but the actual process of making your item doesn't start until they have your specific order in hand.
A great example is a tailored suit. The tailor has bolts of fabric, sure, but they are not going to cut into any of it until you've been measured and you've picked out exactly what you want. This gives you a ton of personalization, but, as you can probably guess, the wait time starts to stretch out.
And finally, we get to the most complex, most customized strategy of all, engineer to order. In this case, you're not just ordering a product, you're actually part of the design process. The thing you're buying doesn't even exist on paper yet.
We're talking about huge, one-of-a-kind projects here. Think about commissioning a skyscraper, a custom-designed house, or a super yacht. The customer is right there in meetings with architects and engineers, making critical design choices long before anyone even thinks about buying steel or concrete. This is the absolute peak of customization.
Okay, so we've got our strategy picked out, MTS, ATO, MTO, or ETO. But now, how does that choice actually translate to the factory floor? How do you physically arrange all the machines and people? Let's take a look.
Generally, you'll see one of three main layouts. There's a functional layout where you group all the same types of machines together, like all the drills are in one corner. There's a cellular layout, which creates these little self-contained work zones. And then there's a fixed position layout, which you'd use for something massive like a ship, where the product stays put and the people and tools come to it.
That cellular layout is a really smart way to do things. By putting all the different machines needed for a specific family of parts into one cell, you're essentially creating a mini assembly line. This cuts way down on the time it takes to move parts around the factory, and it lets the workers in that cell become true experts on what they're making.
But no matter how you arrange the machines, running a successful factory isn't just an art, it's a science. And like any science, you have to be able to measure things. So let's see how managers actually measure the flow of work moving through the system.
A really important idea here is work in process, or WIP.
The easiest way to think about it is like water in this tank. All the parts that are sitting around waiting for the next step, that's your inventory. And it acts as a buffer, making sure that if one machine stops for a minute, the whole line doesn't grind to a halt. And believe it or not, there's a beautifully simple but incredibly powerful formula that connects all of this, and it's called Little's Law. This little equation is the secret key that managers use to understand and control wait times. It links your inventory, your speed, which we call throughput, and the total time it takes for something to get made.
Let's make this super practical. Picture a bank. The number of people waiting in line is your work-in-process inventory. Let's say it's 6 people. The speed of the teller is the throughput. They serve one customer every 4 minutes, or a quarter of a customer per minute. With Little's Law, we can figure out the average wait time. You just divide the number of people in line by the teller's speed. So 6 divided by 0.25 equals 24 minutes. Simple, right?
So we have our strategies, we have our factory layouts, and now we even have a way to measure the flow. Let's put it all together and see how a company uses this knowledge, plus some real numbers, to make a big decision. Okay, imagine you're the boss. You need to make a new part. You've got 3 choices. You can outsource it, which costs you $200 a part, but there's no upfront investment. Or you could buy a lathe for 80 grand, and that drops your cost per part down to 70 bucks. Or you could go all out, buy a huge machining center for 220 grand, but then each part only costs you 15 bucks. So, what do?
Well, you do the math to find what's called the break-even point. Let's compare outsourcing to buying that lathe. Every part you make yourself saves you $130, right? That's the $200 outsourcing cost minus your $70 cost. So, how many parts do you have to make to cover that $80,000 price tag for the lathe? You just divide 80,000 by 130, and you get about 615. This number is your magic number. If you think you're going to sell more than 615 units, buying the machine is the smarter move. It's decisions just like this, based on some pretty simple math, that drive the entire manufacturing world.
And that brings us right to the edge of the future. We've talked about this clear spectrum, from standardized stuff on one end to totally custom on the other. But what happens when new technologies like 3D printing and advanced robotics get even better? Are we heading toward a future where we can get the speed and cost of a mass-produced item, but with the total personalization of a custom order? Will that line in the sand just disappear? That's the big question that's shaping the future of how everything gets made.